The economics of energy efficiency require the calculation of net present value and the levelized cost of electricity. $1 of this year equals to more than $1 of next year due to inflation. So we need to calculate the present value of future costs and benefit. The net present value, NPV, is the sum of the present values of incoming and outgoing cash flow over a certain time period. We can use this equation to calculate NPE. The benefit minus the cost and the total benefit and minus cost over the 1 plus the discount rate to the nth power, where n is the number of year. The levelized cost of electricity, LCOE, can be calculated using this equation. CI is the upfront capital investment. CO is the operation and maintenance cost every year. R is the discount rate. We need to sum up the capital cost and the present value of the future operational and maintenance cost. And then we will divide the cost by the total amount of electricity we can save from energy efficiency. Now let's use the refrigerator case to demonstrate how to calculate LCOE for energy efficiency. So this refrigerator is an Energy Star refrigerator. The estimated annual electricity consumption is 594 kilowatt hours. Based on the estimation that the electricity rate is about 12 cents per kilowatt hour, the estimated yearly energy cost for this refrigerator is about $71. The price of this refrigerator is $1,550. The lifetime of the refrigerator is 30 years, and the discount rate we can use 7%. Assume that the refrigerator is 30% more efficient than a typical refrigerator you can find in the market. What is the LCOE for energy efficiency? Let's try to use this equation to calculate the LCOE. For a typical refrigerator, the annual electricity consumption is actually over 848 kilowatt hours. So energy savings from this refrigerator is 254 kilowatt hour every year. So the estimated benefit from this refrigerator is $30.8 every year. We can plug in the 1,550 to the equation at the upfront investment, CI. The $30.8 is the benefit we get every year. So the total cost will be CI minus the present value of every year benefit, discounted at 7%. And then we sum up all the electricity savings, 254 kilowatt hour times 30 years. And using this equation, we can get a result that the LCOE for energy efficiency is 14.97 per kilowatt hour. At the same time, we can take away this calculation a little bit. The assumption of discount rate at 7% is pretty high, especially when you compare this discount rate with the interest rate you can get. Typically, the interest rate you can get is no more than 3%. So what will happen if we plug in 3% instead of 7%? If we use the same equation to do the calculation, discounting the benefit at 3%, we will have an LCOE at about 12.2 cents per kilowatt hour. Some may argue that 3% is still too high because their money in the bank basically gets zero interest rate. So what will happen if we change the discount rate into zero? The result from that is LCOE of 8.2 cents per kilowatt hour. So this case actually demonstrates how we calculate the levelized cost for energy efficiency. You can use this to compare energy efficiency with many other technologies such as solar, geothermal, and wind.